Hey GCSE physicists, what's the crack? So in this video, we're going to go over how to use your calculator. So as you see, I've got a calculator here. I think Casio is the one that's the best. Highly recommend. And you can see I have my Casio one. I've had this one since I was like no age, so I was like 15. Okay, you need to know how to use calculator. Yes, if you do forget your calculator, you can raise your hand in exam and they will give you a calculator. However, there's loads of different versions right now, and some of them don't even have an equals button anymore. Okay, so just make sure that you know how to work your calculator, because the worst thing in the world is you go to your exam, go to your physics test, and you don't get your grade 9, don't get your high grades, all because you couldn't type the buttons in, right? So this video, we're going to go over what standard form, about decimal places, about recurring decimal places, and how to use that square and the square root button. And hopefully then that should get you sorted for your exam. So the first thing I want to talk about is, let's say we look at the equation work done. Okay, so there's a page on this in my resources. It says work done is equal to force times by distance. Okay, so that's an equation you need to give in your exams. But let's say a question tells you that 5 joules of work is done to move, let's say, a box 6 meters, right? And we want to know what is the force. So in my calculator, I just pop the numbers in. I know work is always measured in joules, so 5 is equal to force, I don't know, multiplied by the distance. Distance in physics always measured in meters. It's my number 6. Okay, and again, we're going to learn about this in the topic in the pages. So if you don't remember how to do work done, just go to that work done page. So if I want to calculate force, remember the opposite of multiplying by 6 is dividing by 6. And what we do to one side, we do to the other side. So calculate force, what I'm doing here is 5 divided by 6. So in our calculators, if I just pull it up again, what we're doing right now is we're going to do 5 divided by 6. I hit my answer, and then hopefully you can see that's a fraction, right? In physics, you can't have any fractions. So you get rid of that fraction, you hit this button here, just say like the S to D button, hit that button and it just gets rid of the fraction, it gives you decimal. So my decimal now says 0.83, sorry, with that little dot above the 3. And what that means is a recurring number. So I'm just going to write that down now. So it says it's 0.83, with a little dot above the 3, and that's the number of my force. Now, I said you can't write fractions in physics. You also can't write recurring decimals in physics. So what that really means, it means it's 0.8333333, etc. We can't write this in physics. So I would normally say you want to go to 2 decimal places. So that means there's 2 numbers after that decimal place. So 2 numbers after the decimal place will be here. Because this number is less than 5, it means we just leave the numbers alone. So what my force comes out then is 0.83, and forces are always measured in newtons. Okay, what if the box, though, got moved instead of 6 meters, let's say got moved to 3.6 meters, right? So we're changing the question slightly. So again, instead of 6 meters, we're going for 3.6 meters. So again, my work done is equal to my force times my distance. Again, we said the work is going to be the same, 5 joules of work. So 5 joules is equal to some force times my distance is 3.6. Now I want to get the force by itself. Remember, the opposite of multiplying by 3.6 to get rid of it is divide by 3.6. What we do to one side, we've got to do the others. So what I'm doing now is 5 divided by 3.6. So if I pull up my calculator, again, wherever she went, what we're doing now is we're going to clear that. We're doing a new problem. We're going to do 5 divided by 3.6 equals. Okay, again, I got a fraction, so I've used that SD button to get it off a fraction to decimal. And I can see it's 1.38 with a little dot above it. Now that means it's a recurring number. So I can't use recurring numbers in physics, but I'm just going to write that down. So my number is 1.38. So what I got there for my force was my 1.38, the little dot above it. So remember what that means is 1.3, and then the 8 is recurring. So it repeats, 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 repeats. Now we said we want to do 2 decimal places, so 2 numbers after decimal place. So I can see this next number here is above 5. Remember, the rule is if the number is 5 or above, it makes the number in front of it always round up. So that's going to be is 1.39, and force is always measured in newtons. If you want to write 1.4 newtons, that's also fine. I just quite like 2 decimal places. Okay, what about the squared button? So let's say we got a different type of question in our physics test, and let's say we're going to kinetic energy now. So let's say something told us that we want to calculate how much kinetic energy an object has. So kinetic energy is objects that are moving. And there's a page on this in my resources. Forgot how to calculate kinetic energy, you just go to that page. But the equation sheet says it's 1/2 of mv squared. Now let's say we got an object that's got a mass of 20 kilograms And let's say it's moving at a speed of 3.4 meters per second. So I want to calculate its kinetic energy. What we do is we'll half on our calculators. 1 divided by 2 is a half, 0.5. Multiply the mass in physics is always measured in kilograms, times by the speed, which is my number 3.4, and now we're squaring the number of 3.4. So what I have to do first is I would simplify my equation. So I would quite like a half times 20. So if I want to do a half times 20 in my calculator, I know that's going to be 10, but just to prove it, what I could do again is my 0.5 multiplied by my 10. And I can see that number is going to be 5. What? Sorry. That's why you should always double check your maths, because again, everyone can make mistakes typing things in. 0.5 times by 20, I apologize, is going to give us number 10. So what I'm doing now is a half times 20 was 10, and we're multiplying by that 3.4 squared. I want to simplify that again, right? 10 times what? What is 3.4 squared? So if I just pull up my calculator again, if I pop in here 3.4 and I want to square it. So 3.4 squared means you multiply by itself. Your calculator is that little button x squared there. So I've already told it what x is. X is 3.4, and I just hit that square button. And you can see it says now in my calculator 3.4 squared. So now I just hit equals, see what it says. And again, I get a fraction, I don't like it. So I hit that S and D button to get a number. It says 11.56. So I know that 3.4 squared is 11.56. And then all I do now is I just multiply those two numbers together to get my final answer for kinetic energy, which is going to be 115.6, and kinetic energy is always measured in joules. Okay, let's try something else with the square button. Let's say we've got a different question. So one of the other topics you'll learn about is power when you do paper 2. So let's say we've got a question about power. Let's say our question says that we want to use the equation power equals I squared times by R. What this says is power is current squared times by resistance. Okay, we've got a page in this in my resources on power, so just go there if you want help with this equation again. But right now we're just practicing our calculator. So let's say it tells us the power of some device is 60 watts, and let's say the resistance of that device, that piece of equipment, might be 10 ohms, and we want to know what is the current. So I pop in the numbers I know. The power just told me is number 60 equals the current squared. Now remember the percentage term means they multiply by the resistance. The resistance told me is 10. So now I want to get current squared by itself. I is what we always use to represent current. To get I by its squared by itself, and you get rid of this multiply by 10. The opposite of multiplying 10 is divide by 10. What we do to one side, we do the other. So I'm doing 60 divided by 10. And that number in my calculator, or if I know it in my head, 60 divided by 10 is going to be 6 is my I squared. I want I by itself. So now if I get I by itself, I have to do the opposite of squaring something, which is square root in it. And we do one side to the other. So my I now is going to be my square root of my 6. So to see how to do it in your calculator, again, if I pull up my calculator, what I want to do is just clear that so I can start again. You can see there's a square root button. So I hit the square root button, and I just want to tell it the number I'm square rooting there is 6. And then I just hit equals to see what the number is. I put my SD button, see it will give me a decimal. It says 2.449. Okay, so it would say 2.449 is what I would read. So if I write that down, it says 2.449 is my current. Now, I said with 2 decimal places is best. So we do our 2 decimal place again. Remember our rule, if the number was 5 or above from over here. So again, my number is 5 or above, which means I round up. So my current is actually 2.45. Then if you remember, current is always measured in amps. So 2.45 amps. Okay, the last thing I want to talk about is standard form. Okay, so let's say we're doing the waves topic. So waves is a topic from paper 2. And there's the equation that says wave speed is equal to frequency times by wavelength. You might think, what on earth is that letter? It's a Greek letter. We basically ran out of letters in physics, so we started going to the Greek alphabet. So you might have heard of like alpha before, beta before. So alpha, beta, gamma are all types of Greek letters. And this is another Greek letter, but what it represents in physics is just wavelength. Right? So V represents speed, like it did up here before. There's speed, and F is our frequency. So let's say we're looking at EM waves. So again, if you forgot what EM wave was, there's a whole topic on EM waves. Right now, we're just going over practice in our calculator. So one of the facts you'll learn, or that you've already learned, is electromagnetic waves all travel at the same speed in a vacuum. And we can model this the same way as air. So let's say in air, they all travel at 3 times 10 to the power of 8 meters per second. So what that means is 300 million meters per second. Okay, this is standard form. Okay, so what it means is 3, and we make it 10, 8 tens bigger basically. So what I would do is, let's say I got my number 3, I'm moving it 8 tens bigger. So like 1, 2, 3, 4, 5, 6, 7, 8. So my 3 is actually there. And then the rest of those little spots fill up with zeros. So there's 1, 2, 3 zeros, 1, 2, 3 zeros. So you can see that's why it's 300 million, 306 zeros meters per second. So like speed of light or speed of all EM waves in a vacuum. Right, let's say we're looking at radio waves. Okay, everyone knows, or most people have a radio in the car. Let's say the wavelength of our radio waves is 4 meters. And I want to know then, what is the frequency? So I fill my numbers in my calculator. I know that the wave speed is equal to frequency times by wavelength. The wave speed is 3 times 10 to the power of 8 equals some frequency times by the wavelength is 4. Now you can enter the number 300 million in your calculator if you want, but it's quite hard to do because sometimes people forget a 0. So 3 times 10 to the power of 8 is better. So when I get frequency by itself, the same rule as before. If I want to get rid of this, multiply by 4. The opposite of multiply by 4 is divided by 4. We'll do one side, do the other. So my calculator, what I need to know is 3 times 10 to the power of 8 divided by 4 to figure out what my frequency is. So just so I do that in the calculator. So if I pull up our calculator and we clear it, so we can start again. What I'm going to know is 3. I need times 10 to the power of 8. So you see there's a button here that says times and the x. So I hit it, but then I need to tell it what I want that x to be. So I want that x to be 8. So see how it's going to be 3 times 10 to the power of 8. I know it looks like a big number, but that's what, do you see here? It's the little x is above. You're just told what the x is, 3 times 10 to the power of 8. Now we're going to hit divide by our number 4, same as we normally do. Hit equals to get a number, and I can see it's 7, 5, and what you can do is you can count all your zeros. So count my zeros here, I see there's 3, 1, 2, 3, 4, 5, 6 zeros. Again, you can see it took me a minute, right? Take some time. So I could write down 75, 6 zeros, or there's a fancy button in your calculator called an engineering button, or ENG. You hit that button, it puts into standard form for you. Okay, so if I hit that button, it tells me it's 75 times 10 to the power of 6. So in my physics test, I can say the frequency is 75 times 10 to the power of 6. And frequency is always measured in hertz. Okay, or I could have wrote the 75 with the 6 zeros, 1, 2, 3, 4, 5, 6, and the frequency is measured in hertz. Either one is fine. You will get full marks for both of them in your exam. Some of you studying maths might think, oh my goodness, you can't write that. That's not standard form. It's supposed to be, 7.5 times 10 to the power of 7 hertz. That is also fine. If you really want to do that, again, like I just said, that's also fine. So you could write 7.5 times 10 to the power of 7 hertz if you want it. They're all the same number. However, why bother when in physics this is completely fine? So whatever your calculator says, just pop it in. So if your calculator says this number, just write that number down and be careful to count the zeros. If your calculator says this number, just be careful to write it down and count your zeros. Okay? Or use that ENG button. Hopefully you find this helpful. Key thing is you cannot leave your answer in fractions physics. You cannot leave your answer in recurring decimals in physics. See if it's 2 decimal places, but it's okay if you do your 1 decimal place. And just remember, if after the decimal place, if the number is 5 or above, you go around the previous number up. Okay. Hopefully this is helpful. I hope you kill your exams, and please check out my resources for loads of extra help.